This video is about how I was able to fix an APC uninterruptible power supply that had developed a strange pattern of randomly switching over to battery power for a second or so, even when the incoming AC power was fine. At first I thought it was due to electrical noise on the AC line, but found out by some measurements that that was not the case. There were occasional voltage spikes on the AC, but they didn't happen at the same time the UPS switched over. Gradually, the random switchovers got more frequent, and then finally the output to the desktop computer started dropping out during these transfers, which desktop computers don't like. If you've ever had your day ruined by losing all your work when the computer suddenly dies and restarts, you'd know that's when this UPS had to come out of service. Mine's not very old, but it was already out of production and out of warranty, so the only thing APC would have done is sell me a new one, which I couldn't afford, and I wasn't inclined to buy the same future problem from APC again anyway. So I looked online for servicing information and schematics, but I couldn't find anything like that for my model. Apparently that information is carefully locked up by APC. Then I looked for what others have done as fixes and found one case where a guy had found a bad electrolytic capacitor. His board didn't match mine, but I guessed I might have a similar problem. So the first challenge would be to check the electrolytics on my board without removing them and without knowing what they did in the circuit. Now I haven't gone into disassembling the case on this unit here because I see that covered in other YouTube videos, and that will be the least of your challenges anyway, except for a locking hook inside my unit's plastic case panel that has to be broken off to get it open. APC is clearly trying to keep the user from servicing this product, but your only other choice is that it becomes an expensive paperweight or goes into a landfill, so you have nothing to lose at this point. Turned out my board was not as easy as this other guy's board, as the electrolytics on the logic board were all surface mount, as you can see on the left. So I had to rig up a method that injects a high frequency AC current that's biased up with a DC voltage so that the capacitor never sees a polarity reversal. So I set it up for 30 kilohertz at about 0.6 of a volt peak to peak and about a half a volt of DC bias, using a generator with a standard 50 ohm source impedance. If the electrolytic is good, it'll short out the AC part of the signal but not the DC part. If the capacitor is shorted, then both the AC and DC voltages will go to zero. If it has high ESR, which means equivalent series resistance, the AC part of the waveform will not completely disappear. And if the capacitor is open, then the AC part will stay the same as it would be with nothing connected. So using a couple of sharp needle probes and being careful about polarity, I probed all the capacitors that might cause a random symptom like this, and by golly, 7 of them had problems. 2 were completely open, in my case C40 and C41, and the rest had high ESR. None of them were shorted. I marked the bad ones with a red dot. By the way, anytime you're working on an electronic circuit board, be sure to always wear a grounded wrist strap. So now came the challenge of replacing surface mount electrolytics, which calls for a properly sized desoldering tweezer that could get into the side pads where the capacitor legs are soldered. Fortunately, the capacitors that tested the worst in this unit were accessible with my desoldering tweezer. But there were a few that tweezer couldn't get into, but they were okay, so I just left them in. So to desolder these kinds of electrolytics, you have to heat up both sides at the same time while gently pulling up on the capacitor body with forceps or tweezers. This is tricky because any force that rips up a board trace will make your day a lot worse if it doesn't ruin the board completely. So don't try this if you're not comfortable with it. Here are the 7 caps that were successfully removed, as mentioned before, 2 of them being completely open. So now the question is what to put in their place. Obviously, I didn't want parts like the ones that came out, so I substituted radial type caps with the same capacitance but higher voltage ratings than the originals, and the leads shaped to fit the SMD pads on the board. This way, a regular micro soldering tip at 600 or 700 degrees F can do this one lead at a time. So now for the acid test. Did this fix do the trick? Fortunately, the answer was yes, and the UPS no longer does these random switchovers and cutouts, and I hear a lot of people have had that problem. So as for lessons learned, in a system that's out of production and warranty, don't expect any repair help from the manufacturer. Secondly, bad electrolytic capacitors were the problem in this unit, as I had guessed. And it really sucks having cheap parts that are deep inside an expensive system. And last but not least, always replace cheap parts with better ones. In this case, ones with a higher voltage rating and temperature rating, lower ESR, and easier replacement if it's needed in the future. I hope this is helpful to you, even if your UPS model is different. Just remember that electrolytic capacitors are a common weak link in all circuits that have been in use for a number of years. If you have further questions, please leave feedback, as some of the methods used here might be useful as separate videos in the future. And if this has been helpful to you, please give it a thumbs up. That will help me to know if this video was worthwhile. Thank you.